Okay, so today I want to talk about a bunch of features. If I can get projectors running, that's the next thing. A bunch of features that potentially can enhance your project, and they're worth points and things like that. They're not sort of like required the way that, the project certainly, your project will be, what happened here? All right. You can certainly have a functioning version of the adventure game without necessarily worrying about the features from today, but they can make things all the more polished and interesting and so on. And you are going to want to use them probably in future projects at least. If not, if you've already gotten through things and you were like debating, oh, do I want to try to get it in a day early? Well, maybe with these you'll say, oh, okay, that's 2 easy feature points, so let me take some extra time and I'll put some things in like that. So these are still sort of like general topics, like I said, they'll be useful for just about any game, and particularly we're going to hopefully see them in action in the second game. We're going to start introducing what the second game is going to sort of all be about. But also getting ready for the notion of how do we handle multiple levels or multiple games within a game, right? How do we have multiple games within our project? Because we only have one project that is your main project that we're going to look for, refer to things for, grading, and so on. You can have as many things, and you can even have them all inside of Perforce if you want. But we want to be looking at kind of one project across all of them to see what's in what. So one of the main ways that we'll do that is by this concept of having scenes or scene management. Other engines, sometimes they're referred to as levels. All right, so you have scenes or levels. But the general idea is you have some sort of the current state that we're currently in. And you'll see where sometimes the simple version of just, a scene is a level is the scene, isn't quite adequate for what we want to talk about, but it'll get us off the ground. And my categorization for a lot of the things today, even though they seem like vastly different topics, is that they almost all have one sort of unifying characteristic, and that's this idea of persistence, or things that are going to be kind of kept around while the game is playing, or from session to session. This persistence, right? Persistent things are the ones that stick around, right? So things like keeping the high score, so the next time the game is played, you know what the high score is. Or after you leave a scene, maybe you need to have certain things that just kind of keep going that are persistent throughout the game. The music doesn't stop and start; it kind of just continues seamlessly, right? Things like that. So, I'd like to kick off scene management. Things like alluded to this idea of having sort of a lobby. That's the way I like to handle the projects within a project thing. And I'm sure you've seen games where there were different levels, and eventually you could choose, what level do you start on, what scene do you start on, that sort of thing. So I like to introduce the scene management by creating a lobby scene that you can then select, what part of the game you want to run to. All right. But scenes can be used for all sorts of things. In the obvious ways, like having a lobby or having stages or levels, or maybe having a config scene or config screen, a splash screen, an end screen, a win condition, lose condition, start over, whatever, right? Somewhere you're like, all right, whatever is happening, I want to stop and I want to go into some other state. The game goes to that next either level or stage or something like that. And that's kind of the traditional easy definition. And you probably have seen some of the basics of this scene overview, right? So a scene, normally we might think of it, and we're going to violate this rule right away, but 9 times out of 10, 90% of the time, a unique level in your game which contains the game's environment or the current objects, menus, maybe the heads-up display, the canvas, whatever, right? You've seen in your Unity editor over there on the left-hand side, usually there's the scene hierarchy, everything that's currently in the game. You see it all in there, all your game objects, and maybe there's some objects within objects, and then you have your components within the objects and all that. They're all part of the scene, the current scene. Scenes do exist as their own entities, though. That whole thing, that whole collection of objects there, exists as a scene, a unity scene. You can save the current scene by File, Save Scene, pressing Control-S, and so on, right? Scenes show up, they're saved in your assets folder along with everything else. So you might say, well, what really are these things? I'm saying, okay, I've got this thing that's saved there, all right? To open a scene, that's easy enough. You've probably done this. Double-clicked on your scene asset in the asset folder, or there's also a good old File, Open Scene sort of thing. And you can create new scenes, so you can have multiple scenes. Great. So in your game now, you have scene 1, scene 2, scene 3, and no idea how do you go from scene to scene, right? In a lot of projects I've seen, pardon the pun, where someone will create the adventure game, then they'll create, that's one scene, then they'll create the scene that is the apple dropper game, and then they'll create their shoot 'em up game, and then they'll create all separate scenes. No way to link them to one another other than me having to find in their asset folder somewhere the right scene. Can be kind of painful, especially if the last time you saved your project, you saved it with some other scene than the one that I'm probably interested in grading, right? So the sooner you have some hierarchy to it, the better, right? It's easy enough when there's just a single scene. We just find that one and hopefully it works. Usually there'll be like the sample scene and then the one you called adventure game, perhaps. But the moment you start having multiple scenes, useful to figure out, okay, how do we link them all together? How do we manage them and so on? Now, scenes are on a more conceptual level and in more advanced use cases, we really want to just think them as a high-level hierarchical collection of game objects. Right? So, yes, they form that foundation of we have a scene, quote-unquote, a scene, that's the current running scene, the current active set of game objects. Think of it that way. And so we have a whole bunch of game objects that are currently the ones that are in memory, that are active, that are being used, that are forming the game. And we have other ones that are maybe off on disk somewhere in the project somewhere. It'd be awfully nice to be able to load them in place of the one we currently are in, right? That sort of thing. But they are just this kind of collection. We talked about collections, arrays, lists, and so on. But now this is more a collection that is just established by being a hierarchy. Now how it uses, what Unity is doing inside in terms of keeping lists of game objects or vectors of them or whatever, we don't have to worry about that. Just accept that it's a collection of game objects. Now, like any other kind of game object or any kind of data structure, we can manipulate scenes from scripts. That might sound a little bit weird, scary, whatever. It's like, okay, that's like manipulating the world that we're living in. Kind of, sort of, yeah, all right. But, the 99% use case here, typically we are loading a new scene and abandoning the one that we're currently in. Right? So you have to have some way of saying, okay, something happens causing us to load a new scene. We go through a door, we load the next room. We hit a button, we load the first game. Right? We all know, raise your hand, you all know how to connect a script to a button now, right? So we could have a script that says, okay, when this button is pressed, we go to this scene. When this button is pressed, we go to this other scene, and so on and so on and so on. So to do that, we are going to use the Scene Manager class, right? So just like some of our other classes, like we were able to refer to vector2 or mathf for a floating point library and so on, there's this magical class out there, like the game, when we said gameObject.find, right? We were kind of referring to all of the game objects that were currently in our scene. Now here, we have something called the Scene Manager class, the Scene Manager namespace, that we can then invoke functions, the ones that are static to that class. And we'll talk in a few minutes about what that really means. I'm going to use this word static a lot today, right? That's a big theme of persistence. Static is also sort of like persistent scope and keeping it around and referring to a special version that always exists kind of thing. So imagine when I say scene manager, referring to it by its class name, I'm referring to some, canonical, official class that has features and properties and so on that are shared across all of them, kind of like our math functions were, or our gameObject.find was, right? So The go-to one, the one you're going to use, again, the 99% case, is load scene. Something happens, you want to load a new scene. A couple of ways you can do that. This is yet another example of a overloaded function, meaning it has one name, there's load scene, but load scene itself has some different ways you can call it, depending on what parameters you pass to it. Most of the time, certainly getting off the ground, you wind up referring to a named scene, right? So suddenly your object names are going to pick up some importance here. You know, the lobby, the adventure game, the whatever, right? So you just say, name the scene, you put it as a string. It's just a string in quotes there. Or instead, you could say scene manager.load scene, scene index. You refer to it by the index of the scene. Sounds a lot like you're referring to a member of an array of scenes, perhaps, but you have no idea where is that array kept. Well, maybe it's hiding up there in that scene manager static class. The static class knows about all the scenes, and it says, okay, you want the 5th scene. All right, so it might do that for you. And then fancier ways, you know, get the active scene from the scene manager, get the index to where it is in the build, and load that one. So these last two cases are a little confusing because you have no idea what is this scene index, what is this build index, where are they coming from, how do I know about them, and so on. And it introduces an important feature, and we'll have to go to the editor to see this. And did I have it running? Okay, do. Oh, no, the hub running. Doesn't matter. We'll load the game, take a breath. How's everybody holding up on campus in general? I feel like it's been like already at least like a month and a half or something like that. And I was like, oh, this is the 7th lecture. I'm like, oh, so that means it's the, what is it, 5 weeks? No, it's like just, you know, the 3rd week in or something like that. It's some crazy, 3rd, 4th week. I don't know. We're still so early in the semester, but my brain is all confused. I don't know if anyone else is in that same time warp mode here, but I know it's always a shock to my system. We say, oh, it's actually lecture day 7. Well, that's not all that far into the semester. So, okay. All right, so Unity is loaded, our game is loaded here, our project is loaded. Always comes up at the last one. I was editing here, and you'll notice in my project, there's a scenes folder that has my lobby scene. I'm going to double click on that. Turns out I do have a lobby scene over here. And the lobby scene has a button for adventure game. And then over in assets, let's see, settings, where did it go? The scenes folder within settings. That's some terrible. And where's my other scene? Adventure game. Scenes, that's the other one in there. So they're all kind of all over the place, and potentially. So how is Unity going to figure out, you know, where are all these things? How's it dealing with, you know, how do I know what is scene 2? Now, there's a very important thing over here. Under File, you'll see Build Settings. Now, we're not going to actually build our project, make it an executable that we can put on the web, or make it a distributable that we can, you know, download from somewhere. We're just going to set it up as if we were going to do that because there's some important things about that. So we'll open up Build Settings if you have Unity in front of you. And you'll see the top right there says Scenes in Build. I'm getting totally washed out by this. It's okay with everybody? With the worst possible sun condition here, I guess. So you see at the top we have Scenes in Build. And right now there's just one in there. It's checked. And if you look to the right side here, there's this 0. So I only have the adventure game scene included in my build, and it is build index, or it is the index of that, the index of that scene is 0. So if I were to refer to something or ask to load scene 0, it would be referring to the scene in this list. This is effectively an array of scenes. And I might even go so far as to say, well, what I really want to have happen when my game is running, here, I'm going to put my lobby into the game, and my lobby should actually be the first thing encountered. All right, another thing about scenes is that the 0th scene, the first one in this list, when you actually deploy your game, when you build your game, you're telling it, okay, start in this scene. All right, you have to give the system some way of saying, all right, this is the starting scene. So start there, and then do whatever it's supposed to do. It's not going to know to automatically. It doesn't really, it doesn't really imply too much about how to get from one scene to the other. It just says, oh, okay, at some point you might be doing something in a script that will tell me, oh, I'm going to go from this scene, I'm going to use this other scene. Because ultimately, when you build your game, it has to say, all right, these are all the resources you're going to need out of your potential project that you created. So this becomes the master list to say, these are all of the scenes, the collection of game objects that are going to be the ones that I'm using. Right? So you have to be careful about this. I urge you to kind of set it up right away. So we say lobby scene, adventure game scene, and so on. Don't touch anything else in here just yet. If you are curious, we're going to wind up using the WebGL build, and we'll just leave that alone for the moment. Not going to switch platforms. We're not going to actually build it, do anything like that. We're just going to leave that setting. We want to just look at the scenes and be aware of them there. Right? So any scene that you potentially want to have in your project, make sure it's in there. Right? Later on, you might ask for a scene, and it says, the scene is not in the build. And that's because you didn't put it in there. All right? So that's an important thing to know about. That's where those things come into play. All right. Now, I'd just like to mention this, again, a bit of a recap. It's because we're talking about collections, scenes being collections of game objects. So just have that hierarchy, right? We have our game objects, which are, the current game objects in there, and we're using find for that. And then notice the difference here. Once we have a reference to a game object, then we can reference the components of that game object, right? Familiar with that? Those are the basic ones. Those I expect to see in everybody's code. It gets fancier from there depending on how complex you want your games to be. You can do things like get one or more components of a game object in an array. Like, say, if you had a whole bunch of sounds playing on the object at the same time, and you wanted to get reference to any audio source on that game object, you could do get components instead of just get component. So be careful in your spelling that you don't accidentally do this. It's something worth knowing about. And then even things like saying, get component in children. So if you have a hierarchy of game objects, because you have a robot, and a robot has 2 arms and a body, and each of the arms has hands, and the hands have 5 fingers, and so on, and they become a whole hierarchy. You could ask, starting at the top, the robot, the part of that whole tree, and say, get all of my collider components for that whole tree, using this sort of thing. Get component in children, we'll find the first component of that. And then there's a get components in children that'll find all of the components throughout the whole tree. All right, so it gets fancier than that. You can also be really careful and safe about how you get components. Things like try get component rather than get component. So we'll try, and if you're not sure if it actually had one of those audio components, it'll tell you here. So you can say, oh, if there is one of those components, then do stuff. Then try to play the sound. And if there wasn't, don't try to play the sound. Right? So as you're writing more and more generic code, you might have some script that says, if something crashes into me, play my sound, for example. But you're not sure as you're writing that have the objects that I'm talking about, do they all have sounds? I don't know. So you might have a bug if you just said, play your sound component, assuming that there was a sound component. Right? So you'll see that there are things like this where you say, okay, try to get the sound component. If it fails, don't do it. If it succeeds, go ahead and do it. You can code your own versions of that as well. You get the component, if it returned null, et cetera, but there are like built-in functions also to help you write things that are clear and safe. Right. All right, so let's get back to Scene Manager. We had load scene, which is sort of like, all right, load a new scene. And actually, before I say this part, I don't know if I emphasize this in here. The second bullet here, you can also use this to reload a scene fresh. So if something happens and you want to reload the current scene, restart the game, restart the level, common thing to do, you can load the current scene over itself. And that just means, okay, wipe out the state of everything, destroy everything that's currently in memory, and build it back up from the blueprint, from the actual scene that you created in the first place. So it's a really easy way to start over, right? Just say, Scene Manager load scene adventure game. It's going to restart the adventure game from scratch. All right, go back to the lobby. Same thing. They press cancel. They go back to the beginning of that. Who knows? All right, so that's the idea. The basic ones are load a new scene or load the same scene over again to restart the level. Your most common cases. But now, I mentioned before that scenes are really just collections of objects, right? They're not really, they don't have to be unique in that sense, really. You can think of them as sort of another kind of a meta collection, right? It's a collection of objects, a hierarchy of objects. And there are actually functions that will allow you to do things like, even though you have one scene, load another scene into that scene. So you can have multiple scenes loaded at once. And we do that through additive scene loading instead of just scene loading. So this first one here is an example of yet another overloaded version of load scene, where we give it the scene name that we're interested in, but we tell it specifically the load scene mode, right? And this is one of those, remember, enumerations that we had before? So there are some system-level enumerations for certain types of modes. So we don't have to remember, number 2 was additive load scene mode, right? This is why enumerations become important, especially as we're defining interfaces and so on. So we have an enumeration that we can refer to, load scene mode.additive, which is going to add that scene to our current scene. Pretty cool. So now you can imagine a situation. I'll give you one example if anyone wants to offer up another example. Imagine you had an army of enemies that had all sorts of things, and you wanted to load that whole army at once. You could have their formation, their presence in the scene, and all that kind of stuff just as a scene. Load that into the scene, right? Anyone have any other obvious examples? What would be another obvious example of additively loading?
Sorry, additive is just loading one scene on top of another?
Into that scene, yeah. Okay. So, yeah.
Where there's multiple rooms that have lockings in them, and like as you go through the narrow hallway and hide the loading, you have the other lockings going under it.
Exactly. Right? One of the most common uses of additive scene loading is when you truly have some kind of environment where, you know, you start off in this room and you say, okay, I've got a corridor here, I've got a corridor here, I've got a corridor here, and you don't want to have the whole world loaded at once, right? So you could say, all right, the moment they enter this corridor, I'm going to load this room because there's a door here, and this room because there's a door here, and this room because there's a door here. So I would add this scene to this scene. I can also unload them when I don't need them anymore, right? So if I then visit everything in here and I come back to this main room and I enter this corridor, I might say, okay, unload this one and load this one. All right. There's definitely some overhead. It's a non-trivial operation, but the nice thing is that not everything has to actually be in system memory and active at the same time. You're not doing all, say you have wizards planning, plotting, casting spells, getting all ready to go, lots of AI and things that are being potentially updated and state. You don't want that running for your entire village, your entire city all at once. You only want the things that are in that little bubble sort of around the player at any particular moment. So you load that scene and it runs, right? The moment after you set load scene, all the starts happen and all of the objects in there start doing their thing. So potentially really, really useful. So we have ways to drop scenes. We can get scenes by name and even figure out, are they already loaded? So in this case, it'd be awfully nice at the moment they go into this corridor, we would say, oh, okay, is the corridor, is everything in there, is it already loaded? Important, especially if you've asked for it to load asynchronously. You're familiar with the term of asynchronously? We had asynchronous classes, meaning not synchronized in time. Normally when we're referring to asynchronously here, it just means you might kick off the load and you're not going to wait for it to finish. So if I load something asynchronously, I'm going to ask for it to be loaded, but then I have to do something special to verify that the load completed before I really start using it. So I'll often load something asynchronously, and then the moment I really need to use it, the moment they actually open this door, don't let them open that door until I know that the room behind it is loaded. That sort of thing, right? Yes?
Does every scene have their own game manager?
Does every
scene have their own game manager?
Well, the game manager object, remember, that's just something we created. That's sort of an arbitrary thing. We could have room managers, we could have game managers, we could have anything that needs to, if we have some sort of overall state to that scene, that's why I would use something like a game manager or scene manager, that sort of practice. Scenes don't have to have something called game manager. We just kind of use that as an example to say, okay, everything that's currently going on, we want to have some kind of overall thing for keeping the score and so on. So you could even have a shared game manager that all the scenes share, perhaps, and we'll talk about how that'll work in just a second. So it's anticipating a good situation, right? But scenes don't have to have a game manager. They just, we did it, and it's pretty good general practice to have something saying, all right, those things that are in a scene that don't necessarily belong to a specific object in that scene, you have some overarching manager to keep track of that. But sometimes all the objects in the scene will be completely self-contained and they don't need some overall manager, right? Sometimes they do. A side effect of that is that we have to remember that classes have to have unique names, so it may not make sense to have the game manager script here, or what would do the function, the purpose of a game manager for this scene up here, and this game manager down here would be very different. So maybe a generic game manager isn't the way to go. Instead, we have the lobby manager, and we have the dining area game manager, the dining manager, and we have the dungeon crawl game manager and so on, right? So we might have something like that as well. So it's going to depend on your situation, depend on your design, how that goes. Long answer to a short question, but all right. So highly recommend you try this. Do it. It's probably simple enough to go ahead and do it in your current project if you want. Hopefully nothing breaks, but imagine, create a few simple scenes. They could just be empty scenes if you want, or they could have something as simple as just a single text object in there saying, Scene 1. For future reference, a good way to approach this exercise is to say, well, create a lobby scene. You already have an adventure game scene, hopefully. You may already have a lobby scene, so you have those two. Create a apple picker scene that has nothing in it other than the text apple picker. Create a shoot 'em up scene that has nothing in it but the shoot 'em up. And the last one, nothing but the platformer. The one other thing that's a good idea to add to each of those scenes is a button, and that button should activate a function that says, go back to the lobby scene. Right? So that's the basic idea of the lobby, is that you have a whole bunch of different scenes and some way of traversing the tree. All right, so we start off here in the lobby, and from there we can go to one of our 4 games, and somehow you might get even more complex and say, well, here's the adventure game, and the adventure game has a game over scene, game over, which has a button on it that tells it how to go back to the lobby, but maybe it also has a button that says restart the adventure game. All right, so you have yet another place for hierarchies. All right, figure out how do we navigate through the structure of our game. All right, you start at some base, and then you work to other scenes, and then you may need to make decisions about where to branch from there. Restart that scene, go back to the lobby, jump to a death scene, and after the death scene, so on and so on. Right, all design considerations. So consider this slide as some suggestions on ways to do that as an exercise. So write a script that can be used to navigate from one scene to another when a certain input happens. Clicking a button, and we'll talk about input and keys on Friday. But create an object in your first scene, attach the navigation script to it. Make sure that object will persist across all scenes. Now this is going to be another, we haven't talked this part yet. Imagine we wanted to have a button that was in all of these scenes. So we created in here, and it's the panic button. And the panic button always brings me back to the lobby. And it'd be nice to say, well, even if someone writes a new scene here, you write a new game and it goes there, I want that panic button to be there. So the question is, how do we load a new scene and keep something from the old scene? Now, the asynchronous method would be one way, but we'd be keeping everything from that scene, and that's not really what we want to do. We just want to keep that one button. Can anyone think of another really good example of when you want that sort of behavior where something starts off at the very beginning of the game and it just persists across the whole game? Yeah?
Like a little menu button.
A menu button, something like that. Yep. Any other? Yes?
Like a health bar.
Health bar? Like so something about like the heads-up display for the elements of the user heads-up display or user state, something like that. Yep.
The settings and preferences button.
So similar to, it's the interface to some settings and so on. So the question is, at some point you have to start thinking about, well, are we interested in saving the interface to these things, or is it the data behind them that we're interested in persisting? Right? That's another situation. Yeah. What? The game manager itself might be the thing that persists. Yeah. Very good. No one got the one I was hoping for, because this is the one that people, I'm going to mention it, and you're all going to want to do this the moment I say it. Yes? The inventory. Well, definitely could happen in other games. In our games, it's not going to matter so much because there's no shared inventory across the adventure game versus the apple picker but other games, yes. So the one to mention, or was hoping for, I didn't weed out, is the idea of background music. So you start off with your background music in your first scene, and you just want your background music to play. Right? You don't have to pick new music for all of your games. Maybe you do, but quite often you just want the music to play. Especially once you're in scenes like this and you load, like maybe a situation like this where you go from one level to the next level to the next level. It'd be nice to have the music just continuously play. Or even potentially the player itself persisting as you went from scene to scene, that sort of thing. So the background music is a really good example because it's a nice, simple example. And it's especially nice when you go from, say, your current scene and you put the game over and you want that music to play, and then you want to restart, but you don't want the music restarting and that sort of thing, right? So that one is a good one. So the challenge to that is somehow you need to make sure that there will only ever be one copy of certain objects in your game, like the main background music player, and it should just be capable of playing over and over again, or something important. They only want to have one of that thing, no matter how many rooms, no matter how you go back and forth, and so on. All right. So let me talk about that sort of more advanced topic, right? Persistent game objects. Instead of saying, okay, I'm keeping the whole scene, I want to keep some game object as I move from scene to scene. So for that, we have a special function called don't destroy on load. So normally what happens as part of loading a scene is we tear down the whole current scene. Unity does it for us. Destroys everything, wreaks havoc, gets rid of everything, yanks the rug out from all of our stuff, restarts the whole scene. We're allowed with this, at any point during our running script, we can pass in a game object to this. And that game object gets a little flag set on it, saying, okay, next time you tear stuff down, or actually whenever you tear stuff down, you tear down a scene, you do a load, don't destroy this one. Keep this one around in the hierarchy, right? So this one will stay. So imagine we have the audio manager that's busy playing the background music, and the first thing we did as we went into the scene, or during awake, which is an awful lot like start, right? We have an awake function and a start function that we'll talk about subtly. They're subtly different, but for now, consider them to be similar, just that awake happens before start happens. So we would call don't destroy on load this game object. So this way everything else in the scene dies because it's getting restarted, except for this thing. Seems like a straightforward idea, right? And this becomes sort of a common pattern, right? Imagine that you create a splash or loading scene before your start scene. You set up your persistent object so you can reload that start scene without issue. So you kind of have something that happens just once. So now you say, okay, before I even get to the lobby, I have a one-shot scene, a setup. And I do anything I want to persist throughout my whole game. I set up there and I call it don't destroy on load. And I never come back here again because those things are all set up and I never need to set them up again. Because once something exists, hopefully get the, once something exists and you say don't destroy on load, it always exists. And the moment you create a scene that has that type of object in again, it'll create another one, right? Just because you're not destroying it doesn't mean don't create a new one. So the problem is what happens if the scene already has one of those, right? We say, all right, we want to play the background music throughout, so we load a new scene, the background music keeps playing, keeps going. We return to the lobby, which is the place where the background music started in the first place. So we get into this situation where, you re-enter the room, you've got your background music playing, and your scene starts up, which includes another background music player. So we've got the situation where, we only have one chair, we only have one, audio playing. So we need to have this idea of how do we have this chair in there to sort of help us enforce the idea that not only do we only want one to live on, but we can only have one. So the musical chairs analog it'll make slightly more sense. Maybe starting out makes, I think it makes pretty decent sense. It'll make more sense in a second. Right? This is the problem with don't destroy on load. Sometimes you only want one, and if you're not careful and you leave another one there, then you'll keep adding more and more and more. When you really, in your scene, you only have room for one. You only have room for one background music to be playing. Right? So they're going to clash if you don't somehow figure out how to deal with it. So we're going to get into our first sort of official game programming pattern, or really it's a computer science programming pattern in general. Right? There's this notion of programming patterns. We'll talk about a few that are sort of specific to game programming, but as you get into, if you are taking computer science, you'll study more of these in principles of software and fundamentals of computing and so on. But programming patterns are really sort of interesting. It's not like a data structure specifically or a variable or something that we can really kind of put our finger on and say, oh yeah, this is a structure that is a programming pattern. It's a software design pattern. It's a general reusable solution to a commonly occurring problem within a given context in software design. So it's this general approach to kind of a problem that comes up a lot. Now, we mentioned lots of use cases where this don't destroy on load musical chair problem happens, where we want to say, okay, only one player in our game, even though we reloaded the scene that has the player in it. Only want to have one background music playing, even though we reloaded the scene that had the background music playing, and so on. So that is kind of becomes a common problem, not an exact copy. We can't just necessarily cut and paste a solution to it. It's not, there's not a specific piece of software, usually. Sometimes there's some parts of it and some snippets of code that lend themselves to being modified or being reused. So this is this reusable solution. It's kind of like an algorithm, right? An algorithm for solving some general problem that keeps coming up. Right? It's not a finished design necessarily that can be transformed directly into source code or machine code. Sometimes you will have your sort of go-to. Officially, it's this sort of description or template of how to solve a problem that can be used in many situations. And they're also referred to often as sort of best practices or formalized best practices that programmers can use to solve common problems. Right? So, programming patterns, and the one we'll concern ourselves a lot with is this idea of singletons. It shows up in a lot of games, a lot of situations. So in software engineering, the singleton pattern is a software design pattern restricting instantiation of a class to a single instance. Right? I have a class, which is my background music player, and I only want that component. I only want one of that component anywhere. Right? I don't want anyone else. Once there's one of them, it's the Highlander. There can be only one. So effectively, unlike the Highlander, any other Highlanders that show up, we have them just kill themselves. Right? They can't exist. Only one can exist. Brutal, right? Sounds brutal. It's going to destroy itself rather than kill itself. But destroy, right? So useful when exactly one object is needed to coordinate actions across a system. It does come from a mathematical concept, the singleton, this thing that can only a single instance of it can exist. So in our musical chairs problem, after the chair is occupied, right, we have that chair, that one opportunity for an instance to exist. And once someone is in that chair, we say, okay, anyone else who tries to enter the game is not allowed. They see it, they say, oh, I'm not even going to play. The best way to not lose at musical chairs is to not play at all if someone's already in the chair. Right? So after that chair is occupied, don't let anyone else join the game of musical chairs, not the game or game that we're playing. Right? So once we have something playing background music, anyone else who comes along and says, I want to play background music. It's like, nope, they just look, they say, oh, sorry, seat is already occupied, destroy myself. So I know I said there's no one code solution. Here's one, though. When it comes to Unity and C#, you can sort of reuse this for a lot of situations. It's nice. This works out well in C# because of the component model, because we can very limit the scope of the running code to this component, but then the component can have a bigger impact on the object that it lives on. Right? So C# and Unity lend themselves to a reasonably repeatable version of the singleton. And this is one version. And it's an awful lot like the musical chair example. Right? So this is still a monobehavior. It's the singleton component. I've just named it singleton. Right? Why not? And the first thing we'll notice about the singleton component is it has a reference in there, a member that is a private static reference to a singleton. Right? So the first thing a singleton has is a reference to a singleton. So let's imagine having our, it's just a reference that potentially is to myself or potentially is to another member of this class, who knows, but it's a reference to a singleton. Right? Who's taking data structures? Have you done anything with pointers yet? Linked lists? Yes? Okay. So for those who haven't, I'll give you the watered down, real quick version, if that's possible. That's the thing. Often, so in the case of a linked list, what a linked list is, we talked about lists and we talked about how we can insert and so on, and I don't want to get too bogged down in this, but it's important when we look at constructs like this, where say in a linked list I have a node, right? We'll just shorthand this. This is called pseudocode, right? So I have a node, which is a node, it's a class. Hopefully I'm not giving away any homework in data structures. And I have all the stuff that belongs in the node. Who knows what I'm keeping track of in the list. Maybe it's just numbers, or maybe it's an audio source, or whatever. I have some kind of data in here. We'll call it the data that's in here. And the important thing in the case of a linked list, we'll do this real simple, a singly linked list. I will have what is ultimately, I'm going to call this another, I'm going to see this special case, a node, and I'm going to call it next. So within this node is a pointer or a reference to a node. So you can imagine if I have a node and I say that that's a list, what really is happening is that the next one here, will be a reference to itself. If I had a real list, the reference of each one of these would say, okay, reference the next one, and the next one, and so on. And if this was a circularly linked, or a queue, the last one would refer back to the first one. So we'd have this way of going through all of our elements here in this circular list. But each one of them has a reference to, could be itself, it could be another one, could be null. But it's important that we have this idea, we're okay with this, that we feel comfortable with this notion of having a reference to the class from within the class. Because sometimes we'll use that for these kind of groupings, right, for these kind of structures. Right, so here where we see this declaration here where it says singleton, even though we're within a singleton, it's because we're going to have a reference to probably another singleton, or maybe the same singleton, who knows. All right, so that's what's going on there. We have this reference to an instance of singleton. Now, we're going to be really proper and good in here also and say, well, all right, someone may want to know what is the instance that is the master instance, the one that everyone's going to refer to. And so I want to maybe make this public so that anyone can figure out what is the actual instance. So I have the equivalent of a getter function here for this property, right? So I have an instance property in my class. Remember, we talked about getters and setters. Real simple getter here, where if anyone needed to know about something, we're going to have that capital I instance. That's the one that's unique that the external world can see. All right, so that's kind of setting up where we are. Hopefully you're asking yourselves, what's that static thing about? And that's important. Answer that in a second. But let's continue down here. So awake happens, which is any game object that has this component on it will awaken. And it will try to call the awake functions on all of its components. And ultimately, if that succeeds, the start components on all, start events on all its components, and so on and so on. Right? We know about that? Everybody comfortable with that idea? So it comes into being. It awakens. And the first thing it does is says, well, okay, it looks at this instance, this thing up here that is part of the class. It basically looks at the chair in musical chairs. It says, is anyone sitting in the chair? Right? That's what's happening there. If it's null, there's no one in the chair. Right? So it says, okay, if it's not equal to null, right? If it was null, that would mean no one was sitting in the chair. If it's not equal to null, well, that means someone's sitting in the chair. So the idea might be, well, okay, someone's already sitting in the chair, I'm going to destroy myself, right? Because I don't want to sit in the chair if somebody's already sitting in the chair. But we have to be a little bit careful because there are situations where you might be saying, oh, someone's sitting in the chair, and you don't realize, well, that's me sitting in the chair. Right? You have to say, someone's sitting in the chair, and it's not me, then I want to destroy myself. Right? I only want to leave the game if I'm not the one in the chair, and someone's already in the chair. Right? Yes?
So, underscore instance is your is the variable that you're keeping around, and this is the object from this scene that you just put.
This is the component on the current game object.
Okay.
All right. I think I have that. It's always tough to juggle back and forth. So let's introduce one bit of it first. So yeah, that's what's going on. So instance here, we're comparing, is the chair occupied, and is the thing occupying the chair me? Right? If it's not these two things, well then go ahead and don't enter the game. Destroy the game object. Destroy, and ultimately destroy yourself, because you're trying to get in here. Right? Any extra ones that you're trying to get into the game, you delete. You get rid of them. Otherwise, in this case, well, instance, if it got past here, it implies that either no one's in the chair or I'm in the chair. So it's safe to say I'm in the chair. So I'm going to just assert that fact, or not, shouldn't say, I'm going to further say, yes, I am the one in the chair. I'm going to make sure that instance is set to me, and don't destroy this object, because I am the only one that exists. I'm the first one here, or I'm already here, which means I should still make sure, okay, I'm still here. Don't mess with me. Right? So that's the code. And you refer back to this one. Asterisk, mental note. There's an example of an instance in here, or excuse me, of singleton in here. Now, there are a few bits in here which aren't totally obvious, and I want to call out here. And first off is this notion of static. Right? We're going to see static show up in a bunch of places. We see it over here. These over here, they weren't just normal variables, normal data within our class. They were declared specifically to be static. Okay, so typically, if you just declared a variable and then you had a instance of that object would have its own version of that. Right? If I didn't have static there, every game object would have its own instance to refer to. Right? So they'd all have their own instance. And I don't want that, because I want to be able to say they should all reference the same one. Right? There's no need to have, if I have 15 game objects, I don't want 15 chairs, or else I've broken my musical chairs. I've said, okay, everyone who comes into the game brings their own chair with them. That's what would normally happen. But by saying static, it means there's only one chair for them to share. Instance is our empty chair, right? And static means no matter how many of this class there are, there's only one of them. That's the important part, static. Static, a member variable or method modifier that indicates a single occurrence within the class is shared across all instances of that class. So it exists beyond the scope of any instances. Instead of being an instance variable, it's a true class level variable. It exists, one of them exists for the whole class, not for each object of that class type. Right? Important. So it's a shared instance of the class. Remember when we were referring to like math f.clamp, right? We didn't have a math object that we created. We wouldn't want a whole bunch of math libraries. We only just want one of that. We just need one math library. We don't have things like that. So that also is this notion of static, where we have certain classes or libraries that are effectively static that way. We'll look at that a little bit more in a second. So this thing, the other keyword in there that you need to know is special, magical. This is a handy reference to the current instance of the class we are working within. So in our components, we're working within that component. It's a little bit, you have to remember, this refers to the component because that's the class we're in, right? Anytime you're working in C# or C++, whatever, the current version of that object, the current instantiation, the current instance of that object, we can refer to using that this, right? It's shorthand. You don't have to necessarily use this, bless you. You can even just kind of leave it out. So it would be okay to actually say here, just refer to game object and game object. And it would say, well, okay, you didn't declare a game object up here. I'm going to look for a game object that exists for this. It's a good redundancy there, right? So this is when we want to be explicit about the one we're working on, or we want to say, yes, we're referring to the component, this ground we're standing on. All right, so what this comes to. This.gameObject refers to the game object that the current component belongs to. So you do have a way to say, who am I? And that's something that we inherited because we're a mono behavior, right? We didn't set that part up. Remember, there's some things, magical pieces of this, because of mono behavior, there's lots of data, events, and so on that we don't have to declare, but we can still use. So this.gameObject allows any component to refer to its parent game object. Whew. All right. So that's singletons and this and static to some degree. We'll come back, we'll talk about more static in a minute. We'll ramp it down a bit. Player pref's a little easier concept. We go like high and low, right? Scenes, not so bad. Then singletons gets a little wacky and crazy. And we'll come back to player prefs, kind of easier, staple, it's the oatmeal kind of thing. Player prefs, saving simple stuff. Anyone know what I mean by player prefs? What would be an example of player preferences?
Like audio preferences? Like
Yeah.
The audio is set value?
What the volume is set for, something like that. Or other simple things like high score. We're going to see it. I want to see your high score saved in every one of your games, number of moves that it took last time you played it, right? Simple things like that, small bits of data. Integers, I'm going to save an integer. A float value, the volume level might be a float, audio level. You selected this joystick for this player. So that's just a number from 0 to some number of players, right? A simple integer will do it. So simple stuff we can save in player preferences, player prefs. All right, so undoubtedly you want to save some stuff in your game as you get more and more complicated, you may need to serialize larger objects and send them across the network and all that kind of stuff. We're not going to get to that point, but we're going to do simple, small-scale saving of data. Player prefs used to store and access simple data across play sessions, or sometimes even within the game. Like you may say, okay, I want to save something and then refer back to it later on, like the high score, and I want to refer to it in some other scene, and you didn't keep it around through some other mechanism. So sometimes, saving it out to player prefs and then reloading it in another scene because you just wanted some way to refer to it. The nice thing about it is that it's basically saving it to the project. So it's saving it outside of the scene, right? So it's across play sections, across scenes, across, puts it persistently generally on your disk. A quick and convenient way to serialize limited data. So serialization is normally, you think of it often just as making data safe to save, right? If you want your data to be savable, it generally has to be serializable. It has to be able to go from being some complex data structure that has pointers and references and all that kind of stuff to just the facts, right? Crunch it all down, say these are the important parts, these are the unique parts. It actually makes this data, it becomes serializable, kind of concentrates it into the important chunks of it, right? That's serialization. Won't worry about that too much yet, other than to know serialization is all about distilling something to the important stuff that we can then save somehow, or save across an interface like the Unity editor to our scripts. So you don't want to use this to serialize the entire game state. You could get carried away, and it may work. Probably won't work particularly well where you said, okay, someone hits pause, and you want to save the location of every enemy on the screen and each of their hit points and all that kind of stuff, and you come up with some really interesting hierarchy of naming convention and all that sort of thing. You could do it. Not recommended, not efficient, and so on. It's really about small bits of data. And once you see the interface, you can see that it's really kind of designed with that in mind, right? It works it's sort of like a dictionary, right? We talked about dictionaries. You have some name and a value, a key value pair. So player prefs looks an awful lot like a dictionary, except it's a persistent one. It lives on the disk. So you use a string as a key that winds up being bound to a particular type or bit of information, allowing you to retrieve it later. Example, you might have a preference named high score, and you use that to save the top score as an integer, which then you can retrieve later using the key high score again, right? Once you have it named, it persists, you can ask for it back again. So filling out the necessary methods. Here are the general methods of the player prefs. You can do things like delete keys. You can check, does it already have that key, has key? And then the ones that are really the ones you use 99% of the time are the sets, which allow you to set the value of that key pair. Yes?
Is this more like bindings?
Is that what?
All these methods for key bindings?
For different bindings?
Is key bindings?
Well, it's for binding a certain value. It's for saving a certain value under that key. So it's sort of like a binding. It's binding it to a preference, if you will. It's not. I don't want to say like key bindings, like key bindings. You could do that as well, but it's always just really a method to say, all right, there's some data store in your project, and ultimately it says that there is a value somewhere that has this key, high score, and there's a database that you can then look up an integer named high score, and it'll find that value in the database and return that for you. All right, so this by key value pair, think of it as a dictionary or a database. It's kind of the best way to keep that in your head and be most consistent. Right, so you're always going to have some way of referring to it and the return value. You do have to be explicit about the type of data. So there's a set float, set int, set string. Setting the given key to hold the given value. If it doesn't already exist, it will create it for you. So you can say set an existing one, it'll write over it. Or you can set, if it doesn't exist, it creates a new one. And then once you have that, you can use the get float, get int, get string to try to pull a value out of the database, right, out of the dictionary. Retrieve the value stored at the given key. And one nice thing it will do for you is it also allows default values. So if the key that you're asking for doesn't exist in this actual call, you can give it a default value to say, for example, say I wanted to get the high score. I would say get int high score, and I would put 100. So if no high score had ever been saved, when I said get it, it would return 100. If a high score had already been saved, it was 50, I'd get back 50, which would be kind of weird because, well, 50 would be less than 100, so how could you have ever, right? So this is basically creating a default. So in reality, in use, you would only ever get a value that was at least 100 because you initialized the persistent version of it that way. Or you didn't initialize, sorry, you enforced it. If it doesn't exist, the moment you get it, it will substitute in that value, right? You good with that? Right, so simple way, at some moment you say, oh, okay, the player's current score is higher than the high score, therefore set the high score to their current value. Next time you play the game, you come in, you want to know, okay, what was the high score? And you call get int high score 100. It'll either give you 100 or whatever the high score last time was, right? So normally you're doing a get int, get string, get float during some sort of start piece of things. And then either at the end of the game or according to some condition, you set the high score, you write out the value that way, right? So here's some versions of that. So you imagine, there, the start of the game, we check, is there already a high score? If not, maybe we want to create the default. This is, the first piece here is sort of extra. You don't really need to do that because we do have this ability. We could have put a default high score right on this line as well, but if you want to really see the whole prefs demonstrated here, we can do this. So we check, does the key already exist? If not, we create that key. We put in whatever our default high score is there. And then we ask, okay, give me the high score, reading it back from the project, right? And then maybe we actually want to put that on the screen to say, okay, here's the current score, here's the high score, here's a little bit of a way to do sort of embedded formatting in strings. We haven't really talked about that. The nice thing about this is instead of concatenating with lots of pluses to kind of put these strings together, instead you can use this technique in fields to say this would actually print out quote without the braces, whatever your current score is, slash without braces, high score. Right? So it's a convenient way to format your strings a little bit fancier. And then when the game is done, it says, okay, was the current score higher than the high score? If it was, go ahead, save it, and so on, right? So implementation of a high score system, pretty simple, pretty straightforward, no reason not to have it in all of your games, right? It's just a matter of having the time to do it, so plan your time accordingly, and stuff like this just happens, right? Name things accordingly, and you can have multiple scripts. You don't necessarily have to have a different high score saving script for every one of your levels, every one of your games, and so on. If you kind of adopt certain conventions early on, always name things consistently, and so on. Be careful. All right. Okay. So mentioning static before, we've dipped into functions and libraries before, the math, and some of you have done some stuff with random. Getting there, that's cool, that's important. Random is one of the fundamental things, right? What game isn't interesting without a little bit of randomness in there. You always have to roll the dice, or something is happening as a result of some algorithm or process that may need some sort of random fuel to kind of kick it off, or some statistical model that needs to run. Often statistics, the way we create a statistical model and then we perturb it with a bit of randomness and we see what the result is when it comes out at the other end. So having some ability to get random functions, random numbers and so on is important. So let's talk about some of the common libraries, how they work, and how we might even create our own. So libraries, there's no specific thing called a library, really. It's yet another one of these cases where we've been doing this the whole time, and we fooled you, right? They're basically classes, right? So remember when we wanted to get the distance between 2 points, we used vector2.distance because we were, what looked sort of like a library call was actually just a call to a member function of that class. So even in the case of something like math, we're referring to a member function within this class. That's the mathf class. It becomes the library. Right? So libraries are basically classes with member functions that you can invoke without instantiating an object of that class. You don't have to necessarily have, and the math is a good example of it. We never create a math object. We never create a random object. Right? So the typical libraries that we're going to use, we don't create objects of those things. We just use the libraries. Right? Remember, mathf, and so on. So the magic behind this, how this happens that we have these things that seemingly exist without us instantiating them, is our good old friend static again. Right? This notion that for this class, there is one version of that. And sometimes that is data, and sometimes that is a function. Right? So these are methods and data that exist outside of any instance, so therefore we don't need to create an instance in order to use them. Right? So we can just barrel ahead and say, okay, use mathf.clamp. Similarly, we did that with vectors and strings and so on. Right? So even though I've seen people go entirely through this course only, maybe even just using clamp, sometimes using abs, don't want to underestimate the number and usefulness of floating point math operations that are already there for us. Right? No reason to re-implement all your trigonometry functions, or square roots and sines and so on and so forth. It's a fun exercise, and creating your own libraries it can potentially be useful. And it's one of the exercises we typically do in other classes as well. Create a math library. But one exists, and there are some very useful functions that you'll find. I like to point out absolute value. We all know what absolute value is, right? It's just a matter of basically the magnitude of a number, magnitude of a scalar number. So -5, absolute value is 5, and absolute value of 5 is 5. Right? It's just that we have a function to do that. It'll work on floating point. It'll work on integers. We have clamp, which we talked about. Given this value, if it's outside the range, give me the extremas of the range. And here's one I wanted to pull out, because I think we mentioned it, I don't know if it's this class or the other class, the notion of working in floating point math. Sometimes you want to compare numbers in floating point math. Imagine comparing, is this 0? Might be something you want to do all the time. Are these two equal to one another? Are they both, is this equal to 1? But floating point math, it isn't integer based. So there's all sorts of issues with floating point math where if you are looking for exact equivalence, you might run into problems, right? You want to see, did the player wind up at this exact location? Probably in your games, hopefully in your adventure game, you said, okay, were they within a radius? Were they close enough? Were they within 0.5? Close enough to say, yeah, they got there. That's such a common issue that we actually have a math function called approximately. and approximately figures in the actual precision of our floating point math library to say it's close enough. It's within sigma, right? Within the actual error of our library, of our library of hardware and so on, to say, are those two values equal enough? Are they approximately equal? So off by just, you don't get to say what that amount is. That's dependent on really the system. But it'll tell you, so if you think that they're both 0, you can say, are they close enough? And it'll factor out anything like that. So this is a really potentially useful one, right? You have functions like rounding and trigonometry and other things, power, square root, sine, all sorts. I recommend checking it out. Don't assume you always have to write your own functions from scratch. The random library, also yet another class. Two of the main things that we use from that is just, we ask it for a random value, right? We want to randomly figure out, okay, what's the percent chance of this happening? Oh, 50%. Okay, let me flip a coin, or let me call random to see, is it greater than 0.5 or less than 0.5, right? That's my flipping that coin there. So random dot value, notice it's a lowercase v because this is something we just refer to as a number. It's just like an infinite, every time we refer to that property, or that member, we just get a number back. It is just a number. Sort of, that's what it looks like. It's not a function. It has no parentheses after it because it's just asking for a random number. It's like asking for 1, except it's not 1. It's a random number. Right? So that's sort of how this looks. So random value, we'll refer to that. And we also have random dot range because it's often useful to say, well, I want some number that is between this number and that number, right? If I'm trying to say, oh, they should be on the screen, I'm spawning a new enemy somewhere in this location. I don't know exactly where, but I know within these boundaries, within the screen between -5, +5, and so on, right? So random range is useful for that. There's some subtlety to it, though, worth knowing about, worth mentioning. So hopefully in the back of your heads, as you at some point have some bug and you're confused by this, and you'll maybe think back today and go, oh yeah, I can remember that now. It does return a random number between a minimum and maximum value that you provide, returning either an integer or a float, depending on whether min and max values provided were integers or floats, right? You can't do one of each. They should be the same. You should have a float for the bottom, float for the top, in for the bottom, in for the top, all right, when you do that. And there's a bit of peculiar behavior that you sort of need to know about. So remember this, everybody, right? This is this phenomenon of max exclusive versus max inclusive. So both of these, the integer version and the float version, are both what we would call min inclusive. So whatever the bottom number is, we can get that number, right? If I said 0 and 10, I know 0 is a possibility. If I said 0.0 and 1.0, I know 0.0 is a possibility. Now the interesting thing becomes what happens at the high end of that range. Floating point is, integer, just to cover it this way, integer is max exclusive. So if I said random range 0, 10, it will return a value between 0 and 9. Doesn't include the top of the range when I am using integers, right? Handy, and maybe it goes back to the fact that we know things are so often we're zero referencing things, so we want to say between 0 and 9 for my 10 values, right? That's often a thing. However, if you are using a floating point, random range is max inclusive. So if I said 0.0, 100.0, I may get 100.0. So I may get that upper value, right? A little bit of a quirk, but once you know about it, it's just something you know about, okay? So beware of it. So again, now, those are two of our main libraries we'll refer to. You can certainly create your own libraries using static. Talked about static a little bit here. And you'll notice here I've said, oh, okay, here's my math library, and I declared a public static int add2, so I have a function that is called add2 that I can call from anywhere. I don't need an instance of my math library. And I could even go one step further to say, you see that there's a static at the beginning of this whole class definition, meaning that only one sort of, I don't know, do I want to call it sort of kind of like a singleton? It's saying that there is never an instantiated version of this class. It's only a static class. It's only the stuff that exists as static. Everything in there should be declared to be static. Right? So a true static class is basically the same as a non-static class, but that static class cannot be instantiated. Right? You can't use the new operator to create one, so you can't create. It's not that you don't. You can't create a mathf. Right? So the mathf library is a static class, whereas vector, we were able to say vector2.distance, which is okay. So that must have been a static function within that class. But we can also say new vector2. So obviously we can instantiate the vector2 class, so the class itself is not static. Right? So we have these different applications of static there. So static classes are most often convenient containers for sets of methods that operate on input parameters and don't have any get or set internal instance fields. Sometimes they might, if you have things that are just effectively constants, enumerations. In rare cases, maybe you have, global variables, dun, 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 avoid that sort of thing. But be careful about things like that. Sorry. So that's how this is all working. Exposed methods must be public and also static, and that will create, a static library or static class for you. All right. Okay. And I think that's conceptually the meat of today. A lot to digest and think about that. But hopefully it'll kind of make sense as you start, looking at your libraries and considering, how you might create your own, library, useful functions, algorithms, and so on. But I'd like to look now, I don't know if I have enough time, but I want to have sort of a case study on strings, because strings are really interesting. They're very useful. We've all used them probably a little bit, if even just doing a simple assignment, right? We had text on the screen. We needed to take some string and assign it to that thing, right? A string is ultimately a sequential collection of characters that's used to represent text. Hopefully we all agree on that. It is a system-level sequential collection, right? System.char is the fundamental unit within a string. It represents a string, UTF-16 code inputs, right? So on, et cetera, et cetera. The important thing that gets buried, this is the standard official Microsoft definition of strings within C# and so on. Value of a string object is the content of the sequential collections of system.char objects. And this footnote is important but often invisible when it comes to strings. That value is immutable. So we manipulate strings all the time. We think we're manipulating, we're adding them together, we're truncating things, we're doing all kinds of great stuff. But fundamentally, strings are read-only. Every time we start to do an operation on a string, we're really creating new strings. We're moving things around because inside strings are, I warned you, strings are a little bit like, in certain ways, like arrays, but then also certain kind of like classes because they have some other things to them. So the char bit of it really kind of makes it, is really handled like an array, and it is ultimately immutable. So whenever we're operating on a string, we're actually, usually if we want to add a string to another string, we're really creating a new string that has those two strings put one right after the other one, things like that. So something to be aware of with strings. We talk a lot about that, string manipulation, but they are immutable. We're really making new strings from strings, which is cool. We do it all the time, don't worry. One of the reasons we want to be a little bit careful about, text overhead and stuff is because of things like this that just sort of get hidden. Why am I talking so much about strings? We'll see in a second. So one of the methods of strings that you may find particularly useful is being able to search inside of strings for other strings and characters. So imagine you want to find a string within a string. We use something called substring. That's a method of the string class that we can then operate on the strings with. So returns a string. Notice it says returns a string, not the position within a string, not a reference to a position within the string. It returns a string that is equivalent to the substring that begins at the index in this instance, or empty if it doesn't exist. So it's a way to say, all right, I have some string up here. This is my, a set of strings here. Right? There's a bunch of 4 strings. Color 1 equals red, color 2 equals green, color 3 equals blue, title equals code repository. And I might find it useful to find the equals in there because I want to separate them out. Right? So I'd use substring to do that sort of thing. So I'd find, where is the equal sign, and then take out the substring before the equals and the substring after the equals, and I can do interesting things with that. So that's the background story for substring. I just wanted you to be aware of that. Right? Important thing, if you want to subdivide strings, you want to find, from parts of strings and do stuff. Why? Because enough people asked or came up with this idea of creating a pseudo console, right? You want to be able to, in the adventure game or any other game, you want to put up a line of text and something happens, and instead of getting rid of that line of text, you want to put another line of text below it. Seems like a useful thing. Something else happens, another line below it. But we run into the problem, eventually you get to the bottom and you say, well, now what? How do I get rid of the top element? Right? How do I scroll things up? Personally, I'm going to throw this one out there. Be clever with new lines, but let's think, how would you do that? I should have done this where it reveals itself one line at a time. Has anyone gone ahead and done it? Tried to get a console? Sort of? Okay. Certain approaches. So you start off, we'll look at the, I won't have enough time to really dive in and start typing because I'll get one line of code wrong and I'll spend it, so I'll pseudocode talk through the idea here. Typically text boxes, we just have a big text box. Wouldn't it be nice if we just had a text box that auto-scrolled, so as we filled it up, it would get rid of lines from the top and bottom. And maybe as we get more sophisticated about how we build our components, we could do that. But, all right, that might be the one thought. It would be nice to have one big text box that just did it. Or another idea is, well, if we know we want to have 4 lines of text on the screen, maybe we have 4 text boxes. We have a text box for each line of the console. And then we have to be clever and say, all right, I keep track. And I say, the first time I write to the screen, I put it in the 0th one, that somehow I keep track of in an array. And then I put it in the next one, and then I put it in the next one, and then the moment my count is greater than the number of lines I have, I fall back and I say, okay, write to the first one again, right? So I kind of get into one of these situations where I can use a for loop. So imagine I have my string cons, whatever. So first thing I do is write in 0, line 1. Pardon my really terrible handwriting. And then 1 is line 2. 2, and these are the... At some point, I run out of spaces. I say, oh, okay, the one I want to write in is 4. But there is no 4 because when I set up, I only have 4 positions. So what would be one way if I said, okay, the magic number is 4. How do I write the fourth one into this one? What operation would I use? Think back to when we talked about math and useful things. So I've got an integer that is now 4. How can I get 0 out of there? Anyone? Yes.
You could do it by having the actual value be like the mod 4 of the value that's in there be the mod 4 is the value of how many lines per.
Yes, mod. I mentioned this coming in useful someday. Mod is the remainder, right? So if I have my count, and I say count divided by 4, 0 divided by 4 is 0. 1 divided by 4, remainder is 1. 2 divided by 4, 3. 4 divided by 4 is 1 with a remainder of 0. So I can use my mod to then keep cycling through these, right? This is a common practice, right? So if I had a text box for each line of the console, well, it would be a little bit weird because I'd go down and then it'd disappear at the top and everything would still be below it. Wouldn't exactly be ideal. So I wouldn't quite be there yet. Maybe we have this string for each line, which we did there. So we have all the strings in a nice rotating value, but we want to combine those into a text box, into our big text box. So now somehow we have to say, well, I know the count, but I need to write them out. Like if count is 4, this is actually the last one I want on my screen, right? So I have to somehow figure out, okay, write 1, then write 2, then write 3, then write 0 as I combine them into my text box, right? So you'd have to be somehow fancy to keep track of my count and then say, well, count minus 4 and then mod or something like that. So if we were at the fourth one, we would know, we would have to do something where we would say this minus the number of elements. Oh, I'm going to screw it up off the top of my head, but the idea is you need to, I'll leave that as the exercise to figure out, okay, from 4, how do I get the fact that I want 1? And then 5 would be 2, and then 6 would be 3, and then 7 would be 0 again, right? You have to figure out that algorithm. So that's the challenge, right, in this sort of thing. Okay, we're going to things rotating around. Or, do I have a slide for it? I like the approach, and I'll make this a 2-point feature if anyone implements it, because it's cool, where you don't have this. You don't have to get that fancy. And I'll throw down the gauntlet here. If I had a string that was line 0 /n, line 1 /n, right? Does anyone know how would this show up in my text box? 2 /n all the way below. So this /n here is a special escape character, the new line character. You're going to find it useful here and there, especially if you want something to do a carriage return at the end. I think we might have mentioned it. I forget which section. And this way, effectively, we basically have a data structure within our string. We can look at this, we can actually go in there and mine and figure out, all right, where lines end and so on, and create new strings based on where new lines are found. Right? It'd be nice to be able to say, oh, okay, get rid of this, and then get rid of this, and then get rid of that, and append the new stuff at the end. So every time you appended something, it would automatically, for you, get rid of the stuff at the beginning and just append your stuff to the end. All right. So I'll throw that as a challenge, and the hints there are the judicious use of substring and knowing about this new line character as potentially the thing we want to manipulate. Yes?
Does substring also take a ending position?
Yes, there are, you can say, like in this example specifically,
Oh, yeah.
in this one, it doesn't, but normally you can say, okay, substring from that, oh yeah, it does, right here. Sorry, position, and this would give you from that position to the end of the string. Yeah, so good question. You can either say substring from this position to this position, or just from this position to the end of the string, right? So that's a useful one. All right, so throw that down there as the challenge. And I'll just mention, so we start to get in there, so people are reinforced with Project 2's coming up. The classic apple picker, kaboom kind of thing, kaboom with apples. Also known as score points by catching stuff dropped by a randomly moving antagonist before those objects hit the ground. Not the antagonist hits the ground, but the objects. All right, you didn't have to come up with your own design for it, because here I have it designed for you. The enemy has to do certain things. We're going to actually use physics. We're actually going to use more than one game object. We're going to use sprites. We're going to talk about all those elements and so on. So we're going to really let Unity be Unity after this, but you'll have a better appreciation for how all that stuff fits together. So just wanted to throw that in there. And next time we'll talk more about the design that kind of goes into it and the ways that we can code around the need to tune that design, to game test, to play test, and kind of refine our design, so to sort of offensively code so that we can then, or offensively or defensively code our stuff in such a way that we can then tune gameplay later on, right? Don't necessarily want to have a final target and say it's going to work exactly like this, but instead have some parameters to gameplay and so on. So, any questions on today's stuff? It's a bunch. The lecture notes will be up there, so you have some sample code to refer to. The concepts certainly are there. Useful stuff. You can add as much or as little of it to the adventure game if you already think you've gotten everything together. Definitely think about a lobby scene. And also, I'm going to post a video about posting to itch.io. So if you haven't already created an itch.io account, you're going to want to do that. That's going to be the next one. And on Friday, we'll make sure that everyone's Perforce stuff is all there. And then create yourselves an itch.io account. We'll talk about posting things to itch as well. So we'll talk about submissions on Friday. And then that'll wrap up the first adventure game. Yes?
Will we go over how to submit through Perforce on Friday?
Well, as long as you've been doing things as they have been described in the original video, it should already be submitted. Every time you make a change, if you've been doing a submit, it should be there. But we'll go over it just in case, right? But if you see pluses at some point in your Unity window here, you're going to see pluses or it's been touched, and you're going to want to basically, choose this, go to your I don't have it enabled in this particular one. Version control, and it's going to say submit all changes. That's you want to just do that, and it will be automatically submitted. So it's the same procedure that when you set it up and you submit it for the first time. Hopefully that just becomes a practice that you just do all the time. But we'll go over that. Maybe I'll post a video for that ahead of time as well. All right. And this time I'll remember.